Hello. Now we will discuss about combination. What is the combination, Alan?
Yes, ma'am.
What is the combination?
Combination is a merger of several objects.
Thank you, Alan. But your answer isn't complete.
Okay, ma'am.
Any other answer?
Yes, ma'am.
Yes. Please.
Combination is a selection of items from a collection, such that the order of selection does not matter.
That's right, Scott. So, a combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. Combination can be confused with permutations. Nevertheless, in permutations, the order of the selected items is essential. For example, the arrangements A, B, and B, A are equal on combinations, while in permutations, the arrangements are different. Mathematically, the formula for determining the number of possible arrangements by selecting only a few objects from a set with no repetition is expressed in the following way.
We use the combination formula when we have n objects in total and you are choosing r of them. But the order that you choose those do not matter. So we do not care about arrangements or order of things in a combination.
For example,
let's take a look now at combinations, and combinations are related to permutations. The difference here is that we do not care about the order. So if you'll notice, in our last example, we used the exact same set S containing elements A, B, C, and when we found the permutations, we said we could have AB or AC, we could have BA or BC, and we could have CA or we could have CB. And the reason I've obviously written them in this way is because A, B, and BA are really the same set if order doesn't matter. And AC and CA are the same set, and BC and CB are the same set. Again, so when we had permutations, we had 6, but now the number of combinations is 3. So I had to take 6 divided by 2 to get to 3. Now, how do I know what to divide by? Well, that's what we're going to talk about. So again, combinations, we're going to end up dividing by some number so that we take out any of the redundancies. So if you'll recall what we did previously when we had a permutation and choose R, and I'm going to use R here just because I have R combination. Permutation of n choose R was n factorial divided by n minus R factorial. Again, sometimes you'll see it with K, sometimes with R. Now I want to look at what happens for a combination where order doesn't matter. It's still going to look the same, and I'll say again, it might say NCR. I know in the TI-84 that is the way that you're going to see it. Same idea. I'm going to take n factorial, n minus r factorial, which of course represents the number of permutations, then I'm also going to divide by r factorial. Now, what this value does, dividing by r factorial, is finding this number that I need to divide by to take out any of the redundancies. Because for a permutation, we count all of the different ways that it could happen. For a combination, we essentially take out anything that is redundant, anything that has the exact same 2 or 3 or however many values we need. So we're going to divide by r, or k if you're using k instead of r. So let's take a look at how that looks for this question. If I need to find the number of combinations of 3 objects, and I'm choosing 2, then I'm going to take 3 factorial divided by 3 minus 2 factorial divided by 2 factorial. So 3 factorial is 3 times 2 times 1, 3 minus 2 is 1 factorial, 2 factorial is 2 times 1, and I can see that I end up with 3 over 1, which is just 3. So again, that is how you do it. You're going to take the number of permutations and also divide it by r or k factorial.
So, we have finished discussing the combination. An equation?
No question, ma'am.
Do you understand?
Yes, ma,